Thank you, Eric. Maybe I should have renamed it for Forget Web Apps Up. Let's do ably, but no, this is the quest for serverless WebSockets, an adventure with Azure functions and durable functions. So this talk is not purely about WebSockets. It's also not really comparing two technologies together, although I will link to a blog post which compares Azure Web Apps Up with ably. But most of it will be how I built this demo game, which we will also play for a second. So my name is Marc Duiker. I'm a developer advocate for Digrid. It's a US-based startup founded by Mark Vossel. Maybe you have heard about him. He came from Microsoft. One of the co-creators of Dapper. I'm also a Dapper community manager, so that's why I'm wearing that shirt over there. I also brought some stickers. So if you want a Dapper sticker, feel free to grab them here. So these days my work revolves more around Dapper and distributed applications, but before that I worked for ably, so that's why this talk is about using ably as a WebSocket provider. I'm also a Microsoft MVP for the last couple of years, and I really like to draw pixel art, so most of my online appearances I look like that. And maybe you have used VS Code pads. No? There's someone using VS Code, and one of the extensions you can download for VS Code is called VS Code Pets, and it allows you to add these animals in your IDE. I mean, they don't do anything; they just walk around, run around, drive around. But a lot of my contributions are in that extension. All right. So now I need 2 volunteers because I have this highly scalable demo that requires just 3 people, and one of them will be me. So I need two volunteers, just 2. 1, yes, another one? Who will use their phone and then they need to play this game with me. So, yeah, will you? Okay, perfect.
You don't have to ask me twice to play a game.
Okay, perfect, okay, so this is just gonna last like a minute or 2, I think. So you need to go to quest.ably.dev. And I need to go there myself, of course. So no QR code, no, because you never know what kind of URL is behind it, right? I mean, it's like a risk. No, I didn't have time to prepare the code. So this game is like a turn-based game. So we are the fighters, us 3. I will be the edge messaging fighter. Maybe Ed, if you can be the open sorcerer, and then you can be the real-time ranger. So we already have discussed the roles here, and we have to defeat the monster, and that's basically it. So I'm going to do a start quest, and that will generate a session, a game session for us. But then you need to join this quest. So you will see a 3-word sentence, and you need to type that into the quest ID. So now it's going to create a new game, and it's based on serverless, so there's probably a bit of a cold start. So if you could type wiggly-kind-circle in the text field there. I mean, if we were like on the instant messaging, I would just copy paste it to you, but that's not the case. So I'm going to click this edge messaging fighter. I can also update the name if I want, but I'm going to do add player here. So I'm choosing that one. So Eduard, if you can choose the open sorcerer and you the real-time ranger. So now it's saying 2 players still need to join. We see some updates appearing here, and that will continuously show some logging messages. All right, so we've all joined. Now the monster is attacking. It done me some damage, and now it's my turn to attack. So I have this button, attack. So now I'm attacking the monster. 14 hit points, not bad. So now it's the open sorcerer's turn. They do their magic. 6 hit points only, really? Oh, okay. Yeah, exactly. Yeah, it's based on velocity now. So 18-1. That's very good. 18-1. All right, so the monster attacked again, and now he attacked you, the open sorcerer. I'm attacking again, hopefully a bit of a good... 20, so 20 is the max you can get, so that's pretty good. Now the open sorcerer again. 1. Oh, okay. Real-time range again, 12 points, okay, so we're getting there, and we also keep seeing like points appearing, the damage we see appearing. Okay, I think we're almost there, like 29 hit points. 1? Oof, okay, I think that was the worst so far. That was me. It's not doing anything with velocity. So 15 is pretty good. Okay, so maybe you can finish him off. Yeah, oh, perfect. Okay, thank you. All right. So this is just like a very brief demo of what you can achieve with serverless functions, but also some WebSocket-based technologies. All right. I'll do another demo later where we can all actually interact and do something. So I'm going to talk about synchronizing state. I'm going to talk about durable functions and entity functions, because those things have been used to build this game. WebSockets, and then I'll show you the actual solution and go through the source code using a code tour. And then I'll finish with some learnings and alternatives, because although this was a nice example, it's definitely not production ready, and there are actually better alternatives that you can use for some parts. All right. Let's start with synchronizing state. So it's similar what Edward has shown you. So if you have like multiple clients and they need to share some state, there are like basically two options. Either you can do like peer-to-peer things, but that means every client needs to have a lot of business logic, right? So especially if it's about a game, then all the clients need to have this game logic and needs to send their data to all of the other clients. And in this case, it's just 3 clients, but if it's like 100 clients, that means like a lot of communication across all of the clients, so that's probably not the most efficient. So another solution would be to have like a central server, and that contains all of the business or game logic. That would make more sense, and it is more of a scalable solution. And all of the connected clients need to talk to this centralized server. Now, in my example, I'm still using a server, but it's called like Serverless. So it's Azure Functions, which is has all the game logic. All of the clients make HTTP calls. So as soon as we hit this attack button, it makes an HTTP call to Azure Functions. And then what happened is all the clients are also connected with a WebSocket connection to receive all these updates of the new health, the damage that was done, etc. But it's not like this, right? Because we don't have a direct WebSocket connection with Azure Functions. In my case, I'm using yet another service called Ably. Not part of Azure, but it's a very nice WebSocket-based real-time messaging provider. So what actually happens is whenever a client hits a button, that gets sent to the HTTP API implemented with Azure Functions, and the Azure Functions will like invoke an Ably API via the Ably SDK. But essentially it's like an HTTP call that you make, and then the clients are connected with the Ably service. So the updates are sent to Ably and then are pushed through all of the connected clients. So I have a bit of a different diagram later, which is a bit clearer, but this is what's happening. Okay, let's focus on the backend first, about durable functions. So who here has heard about durable functions? Okay, quite some folks. That's excellent, perfect. So it's a package that you can install in your solution. So it runs on top of Azure Functions, and it allows you to have like workflows as code, right? So you can write code, which is your workflow. You can just write activities, and you can execute stuff in sequence and in parallel. And yeah, one of the benefits is that those orchestrations, these are stateful. So these are persisted into, by default, an Azure Storage account, but they can also be stored to SQL and then some other persistence options these days. And that really opens up quite some opportunities. And you can have these really long-running workflows, which could maybe take like hours or days or months. So there's no time limitation on that. Some typical patterns that you can do with durable functions are like function chaining, which is usually the most basic example, right? You need to have a sequence of function calls like ABC. And this is very powerful on fan out, fan in. So you want to call many things in parallel, but then you want to reduce again, want to aggregate over the results. Another example is the monitor pattern. So you want to just run or restart your orchestration maybe every hour or every day. This could be useful for like cleanup jobs, for instance. And final one is called human interaction. So your workflow can actually be in like a waiting state, and it will only continue once it has received an external event. And based on the data on that event, you can go and do something else in your orchestration. So I'm really a big fan of durable functions. It's really powerful, and yeah, you can do lots of different things with it, which is really nice. And one of the newer things, I mean, it already exists for quite a while now, but it wasn't there in the first version, is called entity functions. So an entity function is also a stateful function, so the same as like orchestrator functions, because those are also stateful. But in this case, it combines like an ID and a state, but also a behavior. So it's definitely not comparable with orchestrator functions, because an entity function is just a thing on its own. It doesn't trigger any activities or stuff like that. It exists on its own. And well, if you know anything about maybe the actor programming model, then you maybe see, okay, this is quite similar to an actor, right? Because an actor has also an identifier, it also has some state, and it can also have a behavior. So the entity functions are a sort of implementation of the actor programming model. So this is the example from the Azure docs on how an entity function looks like. So it's just a regular class. You can also implement an interface. You have complete control over this. It uses attributes. So in this case, it's using the JSON property attribute to indicate which values, which fields of this entity function will be persisted. So in this case, the current value will be stored in an Azure Storage account. So this is the state pattern. Then the behavioral part, in this case it has two methods. So it has an add method, so that you can pass in an amount and that will increment this current value. And there's a reset method to reset it to 0. What finally determines this function as an entity function is this function name and then the entity trigger attribute. So this entire class then defines an entity function.
Quick question.
Yeah.
So is this like the serverless way of Microsoft Orleans? Is this their Microsoft Orleans on, let's say, Azure functions then? It will resolve the concurrency problem?
Sort of, yes. Yeah, I wouldn't directly compare it with Microsoft Orleans because I think that's a really quite a mature actor program model. So I think this might something like an actor-light model maybe. So if you want to do some kind of simple actor-like implementation, which is not completely serverless,
but
yes.
It's more tightly coupled with the actor model, so concurrency is #1 priority.
Yeah, exactly. Yeah, indeed. Yeah. There are some downsides which I'll come back in the final part, but yeah, on a high level, yes. Yeah. All right. So that was the function definition, but how do you use entity functions? Well, the final part we didn't talk about an ID yet, so you first need to define an entity ID when you are using entity functions. So you have to use this type entity ID, and that consists of two parts. So there is usually a part that identifies what type of entity it is. In this case, I'm just using the class name. And there is something that really makes it a unique key. So in this case, there's a counter ID, but a more real-life example would be some kind of a GUID that identifies a user or a player or like an email. So something that is guaranteed to be unique. When you want to read some state from that entity, you can use this. You can read entity state async. You provide it with the type you expect, and you pass in the counter entity ID. And what you get back is you don't get back the counter object immediately. You get back a wrapper around that object because maybe you provide a counter ID that doesn't exist. So what you get back, I don't know the exact name of the type, but I think it's called some entity state response, I think it's called. And you can actually ask the entity state response, do you exist? So if it does exist, you've provided a entity ID that exists. So it's good to wrap this entity state in this if clause when if this entity indeed exists, go into the actual entity state, because this entity state here is of the type counter, and then you can access the properties of that counter object. All right. If you want to invoke some of the methods, if you want to use the behavior of the entity, you can use one-way communication. So there's actually two ways how you can interact with it, but the one I'm showing here is one-way communication. You do signaling. You can provide the interface here, which is completely up to you. You specify the counter, and this is the counter entity ID, and then it uses proxies to access the methods there. All right, so this works well. This is quite nice and understandable. There are different ways how to use them. So in this case, in my solution, I'm using entity IDs, and I'm not using them inside orchestrators or whatever. I'm just using a durable client and using the durable client to interact with my entities. There are a few other methods available if you want to interact with your entity ID from an orchestrator function. But that's all in the link here on the slide. All right. And actually, I will show you quite a lot of code about the whole implementation later. But let's first talk about WebSockets. So standard HTTP protocol, we've probably all used it, initiated by the client, makes a request, the server gives back a response, and then that connection is done, right? So there's no more connection there. With WebSockets, Eduard already highlighted this a bit. What happens first is the client initiates it. It sends a handshake request. The server then responds with a handshake response. And from that moment onwards, the connection is upgraded to a WebSocket connection, and where it's bidirectional, right? So clients can send updates to the server can send updates to the client. So that's really quite valuable. And then if either side decides to connect, of course, then the connection is terminated. So now I'm going to show some differences between what the plain vanilla WebSocket API is versus what you can do with the Ably API. So this is plain vanilla JavaScript. It's already shown by Eduard. So if you want to create a new WebSocket instance, you can do new WebSocket and then provide the URL. You can execute some code when this connection has been established. This is the onOpen event. When you want to send something, you use the send method. And when you want to respond to an event which you are receiving in your front end, you use the onMessage event. So that's pretty straightforward. Now this is the Ably SDK, and this is the one for .NET. So it's not maybe 100% comparable with JavaScript. But here you have a specific client, right? So you don't have the WebSocket type, but you have another type, which is kind of a richer client. And that has pros and cons, right? Because the con is that you have to indeed use this in your project, so you have an additional dependency in your project, yes. But this client is also quite powerful, because what happens when you lose your WebSocket connection because you are driving with your car through a tunnel, right? So then you will lose your WebSocket connection, but it does not automatically reconnect for you. But if you use like a richer client type, a richer client SDK, and that can do like reconnect for you. Ably works with channels, so these channels are then generated dynamically. So you have some kind of a client name defined, either as a constant or you generate them dynamically. And once you have a client, you can do pretty much the same thing as with the plain JavaScript. So in case you want to do something when the connection is established, you can use the connection on event when you want to publish a message. So here's a bit different. Because you can actually publish something and you can provide a specific type. So that's the first parameter. So the chat message is actually a sort of type identifier. So you first identify the message, what kind of message it is, and then you provide the payload. For subscribe, you can do the same thing. So you can do like a blanket subscribe. So you can actually ignore this chat message. But I think one of the nice things of using Ably is that you could subscribe to specific message types. So I think that gives a bit more control. So if you only want a client to subscribe to certain types of messages, you can do it like this. All right, now it's time for the solution. First, a bit of a better diagram. So this is the same as I've shown before, but now hopefully a bit clearer. So on top we have all of the player browsers. And they are connected to Ably with a WebSocket connection. And all of the interaction happens all the button clicks happen with HTTP calls that are pointed to the static web apps, because that's hosting our solution. It's a Vue.js solution hosted by static web apps. I'm also using Azure Functions here. So all of the calls actually get forwarded to Azure Functions. All of the game logic is here in Azure Functions. And whenever it's necessary that an update will be sent to the clients, I'm using the Ably SDK here, which actually makes sure I can communicate with the Ably backend, and that will make sure that all of the updates are sent to the client, to the clients. If you zoom in a bit about the Azure Functions specific part, so the browser makes an HTTP request that goes through the static web apps, then comes into HTTP triggered Azure Functions. That will use a game engine class It will create a new instance of this. And this game engine class then uses different entity functions. So there's a game state entity function, and there's a player entity function, and there's actually one entity function for each of the players. So there's actually 4 entity functions, 1 for the monster and 3 for the real players. And all of these classes are able to publish updates to Ably, which Ably then pushes forward to the connected clients. Okay, so I will go through the code and we'll show you the exact sequence what happens, but I think it's also useful if you see like a sequence diagram or an attempt of a sequence diagram first, so you understand a bit of the flow of the application. So this is the flow when a new session, new game session is started, so a new quest is started. So the client clicks on the create request button, that will be forwarded to our HTTP triggered function. That function will also call the method create request on the game engine. And then some logic is there in the game engine that will signal to the init player method of a player entity. And well, there's always a monster, so it will do that first. Then the player entity itself will actually call the publish method on a publisher, which is actually a wrapper around the Ably SDK to call the add player message. Then the game engine will also initialize the game state, so it will create a new game state entity. And that game entity will also publish a message to Ably to indicate we are going to the next phase, which is the character selection part. And then the final thing the game engine does, it will signal to the game state that a player has been added, because we've created a monster. So we are adding that monster to the game state, because I am counting here in the game state how many players have joined, and as soon as there are like 4 players, then I know all of the players are there, and then I can continue to the next phase. All right, so now it's time to look at some code. Oh no, not this one. This one. Okay. So I'm kind of a big fan of VS Code, and one of the extensions in VS Code is called Code Tour. I'm not sure if anyone here has heard about that. No? Okay, and another unique one. So with Code Tour, you can actually record or document your source code. And it allows you to do some kind of like a virtual tour through your code. So you have these things like you can write Markdown like this, and then it will allow you to have like buttons to go backwards and forwards through your code. And it's not only your code you can also have, because this Markdown is not related to any of my code files, but some other points are. But I found this to be a quite nice way of actually documenting a project. I think it's useful for demos, but I think it's also very useful for like onboarding the new people in your project. So what will happen actually is when you create these things, so you also do let's say the recording of this tour also in VS Code, and it will create this JSON file, so everything is in here. So if you need to make some tweaks, you can also do it in this JSON file. But it's saved with your source code. So it's not part of your source code files, but it is part of of the same repo. So I really like this solution. All right, so I'm going to go through this code tour. I'm not going to show everything because most of it is already known information, like this diagram. We know what all the components are in use, so let's move on to the game API. So there are a couple of HTTP endpoints in use. I won't show them all in detail. We'll have a look at the create request a bit later. There's also a get request exists, because it would be nice to actually know, okay, is there a request that a player can join? There's the add player functionality, so that is called when someone joins a quest and selected a character class and provided their name. Then the function that is most used is the execute turn, so that happens when you press the attack button, then the execute turn HTTP function is triggered. And the final one is the create token request. It's very similar to what Eduard also shown. That function will be called once by the front end to actually retrieve an authentication token that will be used when you want to establish the connection to Ably. So I won't show all of the code of these things. Let's go to the actual flow of creating a new quest. So what I'm now going to show is the whole sequence of what I've shown you before in the sequence diagram. So we actually start at the front end to show where the button click is and which function is called, and then I'll show the backend code in Azure Functions and Drupal functions, and then we end up again in the front end with some JavaScript code where the connection is established. So let's start in this view component. It's called start section. And that contains a button, and whenever that is clicked, we will execute the create quest method. So let's go there first. So that's this, and a lot of similar things happens also in what happens in the demo of Eduard. So we generate a unique ID, which is for like the session, right? In this case, so this is the quest ID. So every time we create one, it gets a new ID. And then also here we generate a unique client ID, just based on the GUID. I will come back later to this create real-time connection. So this is the function that takes care of actually establishing a connection to Ably, which then results in a WebSocket-based connection. But we'll do that a bit later. And here we see that the create quest HTTP trigger is being called. And in the body we put the quest ID. And then we get back a new game phase, and that will be that character selection is then the new game phase, so the UI will adapt to do the character selection. I'm also copying the quest ID to the clipboard, because usually when you host a game and you can send the quest ID like via instant messaging or something, so you can easily share it. All right, so the next step is then the HTTP function that creates the request. So it's quite a small function, so it reads the quest ID from the body. Then we create a new instance of this game engine. We provide the Drupal client there, the quest ID, and the publisher, which is just a wrapper around Ably. And then we call the create quest async method there, and we get back to the game phase, which we return. Okay, so let's have a look at the game engine class now. So this is a bit of a bigger class, it's just over 100 lines, so it's still not that bad. So what happens here when you create a new game, then this private method is being called the initialize game state. And that will do a couple of things. It will create this monster entity, this player entity. So, and yeah, whenever you need to interact with entity functions, you need to do that based on an ID. So we're creating a new entity ID here. It's of type player, and then you have like a helper function on the player class. And then I pass in the name of the monster. So that, in this case, it gives me a unique ID. I'm then doing a signaling method. So I'm signaling to the player ID. I want to initialize this player with a couple of values. And here I'm doing something a bit dirty, and I will explain a bit later why I'm doing this. Basically, I was lazy, but I'm providing a new object array, and that object array contains like information about this player, right? It's the name, it's the character class, and it's the initial health, and the quest ID is also in there. So then the monster has been created, so then I'm going to create the new game state entity. So again, I need to create an entity ID for that. And then I'm making two signaling calls to that. The first one is to actually initialize this entity. So I'm passing in the quest ID and the game phase. And the next thing I do is I'm adding this monster player name to this entity. So let's have a look at the player entity definition. So this is the player entity class. So that's you're in complete control over this class. The same as goes for the interface. What happens here when you initialize it, so this is the init player function that accepts the object array of all the player fields. I set all of the properties of this player class based on all of these fields. And here I'm actually calling the publish add player method on the publisher class, and in turn that will actually publish the message to Ably. So I'm publishing the quest ID, the player name. So this is basically the payload. So let's have a look at the publisher class, which is this. And so for each action that I'm doing in the front end, there's a corresponding publisher method. So this is the publish add player. I'm checking if the client is there. Communication is always done on a channel, and in this case, all of the communication is done on the Quest ID channel. Yeah, so if there are like multiple groups playing different games, they all have their own Quest ID where all the communication takes place. So this is the API then. So there's a publish async method on the channel, and here I'm specifying what type of message this is. So it's an add player type, and this is the actual payload. All right, the final thing in the backend is the game state entity. So when we initialize this, then the Quest ID and the face are set from the initialize values. And again, I'm calling one of the publish methods in the publisher class to actually inform the front end that there is a next phase for the game. Okay, so now let's get back to the front end code. So I'm using, so this front end is based on Vue.js, and one of the state stores for Vue.js is called Pina. It's not really, it's not super useful to know, but I'm quickly scrolling here that this is how the store is defined. So every Vue application has this game state store. So there's a couple of things which are captured, like the client ID is captured here, the player name, the Quest ID, but also for each of the players, there's this defined, okay, what's the class, what's the name, the health, etc., etc. So that's all what's defined here. Where was I? All right. So now this is the part, the create real-time connection is called whenever you are starting a game or when you are joining a game, right? Because this once this function is called, this will actually create the connection with Ably. So what is used is the client ID. So this uniquely identifies the client device, and it uses the Quest ID, which identifies this game session. So, well, not too far. So I first determine, okay, is this client already connected? Because if it is, then I don't need to do this anymore. But if the client is not connected, then I'm using the Ably JavaScript SDK to create me a new real-time object. And I'm providing that with an authentication URL, and this then uses the create token request HTTP function. And that will again use the Ably SDK to create me like a valid JWT token. So it's very similar to WebAppSub in that case. So this user has this client has the correct rights to actually set up this client connection. We've also seen echo messages. In this case, I'm setting it to false. It's also very similar to WebAppSub. I'm then saving the real-time client into my store, so I can use it easily. And then there are like a couple of events that I'm doing some stuff with. So in case the connection is established, so in the connection on event, I'm saving that the connection is actually there, and I'm writing some messages to that blue box we saw underneath the players. And then I am going to attach to a channel. So that's the next part. Like I mentioned, everything happens with Ably on communication channels. So here I am actually retrieving a channel based on the Quest ID. And this is something, quite, I think, unique to Ably, because whenever you connect to a channel and you pass in this rewind parameter, this actually instructs the client SDK to actually retrieve the history of the channel. So you can actually look back and replay what has happened on that channel and update your UI accordingly. So I think this is a really nice feature. And they have different SKUs, but in the premium option, you can look back for 2 minutes. But if you have like higher SKUs, you can look back much further. I think the max is like 24 hours or so. The final thing is subscribing to the messages, because unlike WebAppSub, here you can subscribe to specific message types if you want. So here I have different methods to actually subscribe to all of the individual message types. So let's have a look at, for instance, the player is under attack. We're subscribed to this message, and then I'm executing this handler function. So let's have a look at the handler function here. So I'm extracting all kinds of data from the message, so I'm populating all of these constants. I'm writing that back to that blue information box, and then this update player method is called. And this update player method actually updates the Pinia store. So that's what's happening here. And that's and there's still if statements involved. So in this case, I'm checking what is the character class. If it's the fighter, then I'm patching the store, and then I'm updating all of the fighter nodes with the new data. I think there's one more screen left. Yeah, so that's so now at this moment the internal view state has been updated, and that also then cascades then into the front-end component. So this is part of the player unit view component, and that's actually that has all of the properties of a player, right? So in this case, it shows the health, it shows the damage. When the game is over, some statistics have been shown, so how much damage has been done. So we can see the total damage applied, and so on. All right, let's go back. Okay, so while I certainly had fun like making this demo, there were some things I ran into which were not ideal or were maybe a bit different expected than before, and some of them are my own fault. For instance, like the 3-player limit is completely my fault. So I thought initially, okay, let's do some real-time technology where you need like a small group of people, which is like still easy to make, but still useful. But in case like this, right, it would be nice if you could all play, or we could at least all be involved. So this is more like a functional thing that maybe would have been nicer to do differently. So yeah, whenever I make a new version of this, I will at least make sure that there's like a view only option. So because that's still connected to real time, right? Because you still receive real time updates, but there's no real interaction that you can do. So that's one of my improvement points that I certainly will try soon. Another thing that's more to your question. So I've really found that entity function is really quite slow, and in order to understand this, it's useful to know how entity functions work, right? So entity functions still uses like a storage account under the hood, right? I mean, the default implementation uses storage account under the hood, and that uses like storage queues for to dispatch the work, what durable functions does is it's pulling that worker queue. Okay, is there new work? Is there new work? But it's not doing that like very frequently by default. I think the default value is maybe like every 10 seconds or something, or every 20 seconds. So the default behavior is really very slow. You have control over that, so you can actually configure that to a very low number. So I think I've set it now to 1 second, which is acceptable. But it's nowhere near instant. So this can be improved, right? Because you can also choose for like a different storage provider, right? So you can use SQL, or you can use something else like Event Hubs, and I'm sure it will be much faster, but also much more expensive. The same is true for staying on the storage account, because if you like poll every second to the queue, okay, are there new messages? Yeah, you're paying for all of these queries that you make to the storage account. So there are some downsides of using entity function in this case. So I think it's nice when you don't have like very high demands or high requirements when it comes to timings or performance or whatsoever. The other thing which I found a bit annoying, there's these entity operations are limited to 1 argument only. So remember when I do the init player, I create this weird object array and put all stuff in there. But ideally, I would just like to pass like 3 or 4 arguments in the init player method. But that's not accepted. So you only can do 1 argument. There must be some kind of requirement why that's not allowed. I don't really know why. Of course, I could have created like another POCO, right? I could have just created a class that can capture all of that, but then I need to create another class for this. So, not ideal. I mean, there are ways to work around, and there are ways to make it prettier, but why only 1 argument? I don't know. So this is definitely high in my list, right? So there are, of course, lots of different actor frameworks, and them might not all be serverless. So that's maybe one of the downsides for me, because I really like serverless. But yeah, playing with one of these, like Akka.net, like Orleans, or Dapper, and Dapper is the most likely where I end up with, because just the work that I do for them now. So yeah, I think there will be like a version 2 of this application, which then will use Dapper. Which is probably also not one of the fastest implementations, I know, but okay.
Or this one, or after?
Well, the Dapper actors are also, I don't think they're like very performant either. I mean, there's definitely more performance than entity functions. But I think maturity-wise, between Akka.net and Orleans probably the most mature when it comes to the actor model. So Dapper supports actor model, but is not as mature as the other two.
Yeah.
But it's a good session for another meetup. Another one, which is maybe obvious or maybe not, like the free tier of Azure Static Web Apps only supports HTTP functions. And yes, I'm using HTTP functions, but I'm also using entity functions, which is part of durable functions. So those are not supported in the free tier of Azure Static Web Apps. I mean, hey, I'm Dutch, I like free stuff. But so I had to upgrade to like the standard tier of Azure Static Web Apps, or I have to use the free tier, but then set up a new Azure Functions app to host my entity functions. So it's just a bit more work to do. Not a big deal, but you need to be aware of this. So the final one, which I think the most important one, is are WebSockets actually required in this case? So if you look back at this diagram, so the interactions that the players have is that they send a request via HTTP to this part, and then from here information is sent back to the players via WebSockets, but there's nothing going back on the WebSocket channel. And WebSockets are ideal for bidirectional data, but I'm just using it for one direction, which is fine, right? I mean, it's fine, but maybe this is overkill. There's a thing that is called server sent events, which I haven't used that much. I've got like one tiny demo about it, but this could be actually like a good alternative, right? Because with SSE, what happens is just another communications protocol. Again, similar to WebSockets, you have some kind of a handshake protocol first, and then the server can send events to the client. So the client doesn't have to poll. And this connection can stay open for like a really long time. And then, of course, whenever the server is done, it can terminate the connection. But actually, SSE, I think, would have been enough for this demo, right? Because I'm not doing anything from client to server over WebSockets. This is one of the sample apps. I think I should just run this instead of doing it like this. So that's this one. Let me see. I should be able to. It's been a while since I did this. Let me check. So this is like a very basic front end, just an HTML file, which I am just now opening with the live server. So it should pop up here. Yeah, okay. And then we need to go back, and then we need to run this app. And let's see what's happening. Oh, this one. Oh, yeah. Okay. Yeah. So these events that this web page is receiving now are sent via server sent events. We can also dig in a bit to this, but maybe this is too small to look at. Let's not bother with this. But I'm going to show you the code. Let's stop this. So client side is really basic. So this is what happens. Client side. Let's stop this. So again, it's sort of similar to WebSockets as well, right? So you have this vanilla JavaScript type called event source, and that accepts a URL, and that should be your endpoint that sends the events. And then you can do similar things what we saw with WebSockets, right? So there's an on-open event, so you can trigger something when a connection is established, and then there's an on-message event, like exactly the same as WebSockets, which you can use to execute some code when you're receiving messages. So yeah, you can't do anything with typed messages here or named messages. So with that, it has the same limitations as the plain WebSockets API. And it has like an on-error event as well to show some or execute some stuff when errors occur. So the API is, I think it's enough. It doesn't do that much more, but I think it's a nice alternative. If you look at the API, so this is let's show the project. So this is a .NET 7 API, so ASP.NET project, and it is using this external or let's say third-party library. It's called lib.asp.NET Core server-sent events. You can do like server-sent events just with plain system types, but it's not really the easiest thing to do. So I found that using this package, it's really quite straightforward to actually make it work. So what this package provides is, okay, you have some additional helper methods to actually set everything up, but most of the magic happens in this server-side events worker, which is down here. Let me see that. So when you execute async of this events worker, so we actually retrieve the clients to see, okay, are there any connected clients? Because if there are no connected clients, then why should we send anything, right? And then we have this like fake weather forecast we are generating, and here's the send event async that we're then executing. So these are the types that we are now sending over the wire. And so it needs an ID and it needs the data payload, and that's it. So I found this really to be quite a nice alternative, lightweight but nice. Okay, I still have one more demo. So where are we? Yes. Okay. So this one is actually like interactive for all of us. So no QR code, but if you go to pixelpaint.ably.dev, pixelpaint.ably.dev, this is the one. So pixel-paint.ably.dev. There's a connect button there. So this is like a super basic UI. I will actually reset it. But this is like a very basic pixel art drawing app. So as soon as you are at pixel-paint.ably.dev and hit the connect button, okay, so here we see some people are connected. And you can click in the grid here. And we should see also mouse overs of people. And if you click multiple times, then the colors will change. So the colors will cycle from white, blue, pink, and then back to black. Yeah, so this is really like a proper WebSockets demo, right? Because we are actually, this is truly bidirectional. So we are actually clicking, and those click events are then sent over the WebSocket connection to Ably, and that's then distributed to all of the other clients. So there are 12 people connected now. So yeah, this is actually more like a proper demo. But I didn't start with this because this is like purely a JavaScript demo. It's not a .NET demo, so that's why I didn't do this. Eduard mentioned or hinted something about presence. You can't really tell with WebApp how many users are connected to a client or to a channel. But with Ably you can. So there's this number here, user connected. So it's currently 13. So I don't have this on my local machine, but I can show you like the source code here. So if you look at the source code of this solution, this is the part where it connects to Ably. So it's quite similar to what you've seen before. So it's using the create token request API again. We create a new instance of Ably. But what's special here is it does stuff with presence. So what it can detect is with Ably you can subscribe to presence events. So when someone is joining a channel, that is a presence event. So you can subscribe to when someone joins a channel, and you can execute some code when it happens. So in this case, I am subscribed to this enter presence event, and then I'm actually run the add user method here, which makes sure I'm capturing the user information. Where are we? So I'm actually a caption user, and I'm showing all of the numbers, which are all of the client IDs. And yeah, exactly. And you can also change indeed the color scheme, and it also should change then on all of your devices as well. But yeah, the presence is also something that really makes it quite unique to Ably. Well, other providers have it as well, but it's not in either Signal R or Web App Sub. Also, when someone leaves, there's also something you can execute there. And the number you see here, so the total amount of users connected, you can also just ask for that. So we do presence get, and then we can do like for each over every one of them. So yeah, there are some benefits on sometimes on using a different provider than what's already available in your, let's say, standard cloud provider. All right. I think that's it. If there are any questions, now would be a good time. You can also contact me on Twitter, Mastodon, whatever. Oh, wait for the cube. Okay.
Here we go. Hello. I have a question about the server-sent events.
Yeah.
Can you also create some sort of groups or channels or?
I don't think so. No.
So
it seems to be quite like a basic implementation. So I haven't found the ability to also have groups. No.
So that's your incentive to use Ably.
Yeah, exactly. Yeah, exactly. Yeah, if you still need to create some kind of a session or like a quest or session or something, yeah, exactly. Yeah, indeed. Yeah.
You can do some tricks with reactive extensions then. You can do some tricks with reactive extensions and then you will have groups there, but then you're building it all yourself.
Okay.
Yeah. Yeah, and there used to be also like a limitation in older browsers when it comes to the number of connections you can have. Like I think because it's like the connection was like browser wide, so I think the connection limit was six maximum server-sent connection in total, which is quite low. But I think these days you can have up to maximum 100 server-sent connections, which is already quite better. But it's still like a global browser maximum limit. So yeah, if you have lots of tabs open and all of your applications use server-sent events, you could still run into kind of a like limit of your browser. So it's also not ideal for large use case probably. Yeah.
Any more questions?
I have a question about this rewind thing. So if, for example, like I quickly reconnected, like maybe my connection was lost for a second and the rewind is 2 minutes, will Ably handle the duplication of all the...
Yes, yeah, exactly.
So you don't get them twice?
Yeah, indeed. Yeah, that's also the nice things of, so like I said, it's downsides and upsides about using this client SDK. So the client SDK will actually make sure that if another message comes in which you already received, it won't propagate that forward. Yeah.
So Ably is more of it a service provider, or can I host it myself? Similar to the question here.
No, it's really a software as a service.
Software as a service only.
Yeah, exactly. Yeah, I didn't show you the backend, and unfortunately, because I don't have the login credentials anymore, so I can't really show you the backend anymore, which is quite sad. But how the backend works in Ably, so they have a free tier, so it's really easy to sign up. I think it's also quite generous in what you can do in this free tier. But you create applications in Ably, which is more like a logical grouping, and within this application, you can create your channels, or you can create all different kinds of API keys and also assign roles and stuff like that. So it's
a whole service around web sockets.
Exactly. Yeah, indeed. Yeah.
Any more questions?
Thank you for speaking.